Before we begin, a quick disclaimer. The information provided in this video is for educational and informational purposes only and does not constitute professional IT or financial advice. Every business network is unique, and you should consult with qualified IT professionals and network engineers before making any significant changes to your infrastructure. It's 3 a.m. on a Tuesday. You're asleep, but your business isn't. Somewhere in a cold, dark data center, a single line of code in a routine update has just failed. It's a tiny error, a digital typo, but it's triggered a catastrophic chain reaction. Your e-commerce platform is down. Your customer database is unreachable. Your entire national sales team, just starting their day on the East Coast, is staring at a frozen login screen. Every minute that ticks by, you are not just losing sales. You are bleeding customer trust. And the worst part? The person who can fix it, your star IT engineer, is asleep too. By the time their phone buzzes with the first critical alert, your company has already lost tens of thousands of dollars. Does that scenario sound like a nightmare? For thousands of American businesses, it's not a nightmare. It's a reality. It's the recurring high-stakes drama of managing a modern IT network. Now let me ask you a question. What do you think is the #1 cause of network outages in the United States today? Is it sophisticated cyber attacks from foreign hackers? Is it massive power grid failures? Is it hardware spontaneously combusting? The answer is much simpler and frankly much more frustrating. According to major industry reports, over 80% of network outages are caused by one thing: human error, a mistyped command, a misconfigured router, a patch applied to the wrong server. Small mistakes made by good hardworking people that create massive expensive problems. The average cost of just 1 hour of downtime for a mid-sized American company is now over $100,000. For larger enterprises, that number skyrockets into the millions per hour. We've built our entire economy on this fragile, complex web of digital infrastructure, and we're still relying on manual human intervention to keep it running. It's like trying to conduct a symphony orchestra with a single conductor running to every musician, one by one, telling them which note to play next. It's slow, it's inefficient, and it's practically guaranteed to fail. For decades, this has just been the accepted cost of doing business. You hire a team of brilliant, but overworked IT professionals. You load them up with caffeine and pressure, and they spend their days and nights reactively fighting fires. They are digital firefighters, constantly running from one crisis to the next, manually updating switches, configuring firewalls, and patching servers. There's no time for innovation. There's no time for strategy. There's only time to fix what's broken right now. This model is not just unsustainable. In today's hyper-competitive American market, it is a death sentence for growth. Your competitors are getting faster, leaner, and more resilient. If your network is a constant source of anxiety and unexpected costs, you're not just falling behind, you're being lapped. But what if there was a different way? What if you could build a network that wasn't so fragile? A network that could anticipate problems before they happen? A network that could heal itself, optimize its own performance, and scale on demand without a human having to manually type in hundreds of lines of code at 3 in the morning? What if you could free your brilliant IT team from the mind-numbing, repetitive tasks and empower them to focus on what they do best, innovating and driving your business forward? This isn't science fiction. This is network automation. And over the next 10 parts of this series, we are going to pull back the curtain on the single most transformative shift in information technology of the last decade. This is your definitive guide to understanding and leveraging network automation to make your business faster, smarter, and more secure. We're going to demystify the jargon and cut through the hype. We will show you precisely how businesses right here in America, from small e-commerce startups in Austin, Texas, to manufacturing giants in the Midwest, are using automation to slash operational costs, dramatically reduce downtime, and build a powerful competitive advantage. This series is for you if you're a business owner who is tired of IT being a cost center and wants to turn it into a strategic asset. It's for you if you're an IT manager who knows there has to be a better way than spending your weekends on emergency maintenance calls. And it's for you if you're an aspiring IT professional who wants to learn the skills that will define the next generation of networking. We're going to break down exactly what network automation is, and more importantly, what it is not. It's not about firing your IT staff and replacing them with robots. It's about giving them superpowers. It's about taking the routine, the predictable, the soul-crushing tasks that are prone to human error, like device provisioning, compliance checks, and software updates, and turning them over to software that executes them flawlessly at machine speed every single time. Imagine deploying a new branch office network with hundreds of devices, not in weeks but in minutes. Imagine your network automatically detecting a security threat, isolating the affected device, and patching the vulnerability before your security team has even finished their morning coffee. Imagine a network that doesn't just support your business, but actively accelerates it. This is the promise of network automation. It's about shifting from a reactive posture, waiting for things to break, to a proactive, intelligent system that manages, secures, and scales itself. It's the difference between having a map and compass versus having a GPS that automatically reroutes you around traffic you can't even see yet. In today's economy, which one do you think wins the race? So let's start at the beginning. We've talked about the problem, the high-stakes world of manual network management. Now let's dig into the solution. What are we truly talking about when we use the term network automation? Is it just a bunch of scripts? Is it some form of artificial intelligence? How does a machine know how to configure a complex, enterprise-grade network? The answer involves a fundamental shift in how we think about our digital infrastructure, moving from treating our servers and routers like individual pets, each needing to be cared for by hand, to treating them like cattle managed as a collective automated herd. This core concept is the key that unlocks everything, and understanding it is the first step to transforming your business. So let's paint a picture of that old world, the world of IT pets. Imagine a mid-sized logistics company, right in the heart of Kansas City. We'll call them Midwest Movers. Their IT department is run by a guy named Frank. Frank is brilliant. He's been with the company for 15 years and he knows every single server, every switch, every line of code in that building like the back of his hand. He has a server named Titan that runs their core accounting software. He built it himself 6 years ago. He knows its quirks. He knows that on the third Tuesday of the month you have to reboot the network card or it gets sluggish. He has another server, Athena, that handles all the customer data. It's a bit more modern, but Frank still logs into it every single morning by hand to check the logs and make sure everything is running smoothly. These servers aren't just machines to Frank. They're his pets. He named them. He nurtured them. He spent countless late nights and weekends patching them, upgrading them and coaxing them back to life when they acted up. When the CEO needs a new file share set up, Frank gets a ticket. He manually logs into a server, creates the folder, sets the permissions user by user, and then sends an email saying it's done. Takes him 45 minutes. When a new sales guy is hired, Frank manually creates his user account, his email, and his access rights on 3 different systems. This is the world of manual IT. It's a world of digital artisans, where every task is a piece of custom handiwork. And for a long time this worked. Frank was the hero. When Titan went down during the end of quarter rush, he was the one who drove to the office at 2 a.m., worked his magic for 4 hours, and got the system back online just before the accountants arrived. He saved the day. He got pats on the back, maybe a gift card. The business saw a problem and Frank the hero fixed it. But here's the problem with a business model that relies on heroes. You can't scale a hero. Midwest Movers is growing. They just landed a massive new contract, and they need to double their operations. They need to spin up 20 new servers to handle the load. For Frank, this is a nightmare. This isn't just buying 20 boxes. It's hand-raising 20 new pets. Each one needs an operating system installed, configured, and hardened. Each one needs dozens of software packages, each with its own specific version and license key. Each one needs to be connected to the network, given a unique name. Maybe he's on the Greek god theme, so now we have Hermes, Apollo, Zeus, and then manually integrated into the monitoring and backup systems. This process will take Frank weeks, maybe months. And here's the critical flaw. No 2 servers will be exactly alike. Apollo might have a slightly different patch level than Zeus because the security update was released on a Tuesday, and Frank was busy with something else. Hermes might have a slightly different configuration file because Frank was trying a new setting he read about on a forum. This is called configuration drift. It's the slow, silent killer of IT stability. His meticulously handcrafted environment is now a collection of unique, fragile individuals. Each one is a potential point of failure, a ticking time bomb of inconsistency. One day, the inevitable happens. A new vulnerability is announced, a critical security flaw that affects the web server software they use. Frank now has to patch every single one of his servers. He can't just push a button. He has to log into each pet, one by one, run the update, and pray it doesn't break anything. He starts with Titan because it's the most important. The patch goes smoothly. Great. Then he moves to Athena. The patch fails. It has a conflict with another piece of software he installed 6 months ago. Now he has to troubleshoot. Hours go by. Meanwhile, dozens of other servers are still vulnerable, exposed to the entire internet. He's playing a frantic game of whack-a-mole, and the business is at risk with every passing minute. This is the breaking point. This is the moment where the Pets model collapses under its own weight. Frank, the hero, is now the bottleneck. His deep knowledge, once the company's greatest asset, is now its biggest liability. The very thing that made him a hero, his manual hands-on control, is preventing the business from growing and staying secure. Now let's imagine a different world. Let's step across the street to their competitor, Heartland Haulers. They're running a cattle operation. They don't have a Titan or an Athena. They have Web Server 001, Web Server 002, all the way up to Web Server 050. Their IT team doesn't think of servers as individuals. They are identical, disposable units of computing power. When they needed to double their capacity, they didn't give their IT team a 2-month project. They ran a single script. This script contained the blueprint for a perfect server. The operating system, the patches, the software, the configuration, all defined in code. They told the system, I need 25 more web servers. And in under an hour, 25 new, perfectly identical servers spun into existence, automatically configured, automatically added to the network, and ready to handle customer traffic. No heroics. No late nights. It was just Tuesday. When that same critical security vulnerability was announced, the team at Heartland Haulers didn't panic. They didn't start a marathon of logging into individual machines. They simply updated the master blueprint, that single script defining their server. They changed one line of code to specify the new, patched version of the software. Then they told the automation system to repave the environment. And here's where the magic happens. The system didn't try to fix the old, vulnerable servers. Fixing is for pets. You don't fix cattle. The system simply, gracefully terminated Web Server 001 and instantly created a brand new one, Web Server 051, from the new, secure blueprint. Then it terminated Web Server 002 and created Web Server 052. It did this across their entire fleet, like a rolling wave, with zero downtime for their customers. The entire process was complete in the time it took Frank to troubleshoot the first failed patch on Athena. What happened if a server failed? At Midwest Movers, a failed Titan meant a 2 a.m. phone call and a 4-hour outage. It was a crisis. At Heartland Haulers, if database 007 has a hardware failure, the system simply detects it. It marks it as unhealthy. It automatically provisions database 012 to take its place and routes traffic to it. The on-call engineer gets an automated, low-priority email the next morning that says, "Hey, just so you know, a server failed last night. We already replaced it. Everything is fine." The business never even knew there was a problem. This isn't a story about Frank being a bad IT guy. Frank is a great IT guy. This is a story about a fundamental shift in philosophy. The Pets model is built on human effort, tribal knowledge, and heroism. It's fragile, it's inconsistent, and it cannot scale. The cattle model, powered by automation, is built on code, consistency, and resilience. It treats infrastructure not as a collection of delicate, handcrafted machines, but as a fluid, programmable resource. For businesses across America, this isn't just a technical upgrade. It's a strategic evolution. It means your best and brightest people, your Franks, are no longer trapped in the basement, babysitting servers and fighting fires. Instead, they're writing the code that builds and manages the entire system. They're moving from being digital mechanics to being digital architects. They're spending their time on projects that drive new revenue, improve customer experience, and create a real competitive advantage, instead of just keeping the lights on. This transition from pets to cattle isn't just about efficiency. It's about survival. It's about building a business that is agile, secure, and ready for growth. It's about turning your IT department from a cost center that fixes things into a strategic engine that builds the future. So, how do you actually start building this automated, resilient herd? How do you get from Frank's world to the world of Heartland Haulers? It begins with codifying your infrastructure, treating your servers, your network, your entire IT environment as software. And this powerful concept has a name: infrastructure as code. That is the first foundational tool we need to master. Infrastructure as code. It sounds technical, maybe even a little intimidating, but the idea behind it is incredibly simple and profoundly powerful. For decades, we've built our digital worlds. Our servers are networks like ancient cathedrals, meticulously by hand. An expert, a systems administrator, would log into a machine and, like a stonemason, carefully chip away command by command to shape it into what was needed. A web server here, a database there. Each one was a unique artisanal creation. And that was the problem. Artisanal doesn't scale. Artisanal is slow. Artisanal is prone to human error. Imagine you need a new web server for your company's latest marketing campaign. In the old world, a ticket is created. Let's call our engineer Dave. Dave gets the ticket. He logs into the company's virtualization platform. He clicks Create New Virtual Machine. A wizard with 20 steps pops up. Dave carefully selects the number of processors, the amount of memory, the size of the hard drive. He attaches a digital file, an ISO image, to install the operating system. He waits for it to install. Then he opens a command line and begins the real work. He types command after command to set the server's name, configure its network address, and install security updates. Then he installs the web server software. Then he configures the firewall rules. Then he installs the monitoring agent. Finally, after hours of painstaking manual work, he updates a spreadsheet somewhere to document what he did, hoping he didn't forget a step. The server is ready. But is it? Is it really the same as the one Sarah in the next cubicle built last week? Did Dave remember the exact same security hardening command Sarah used? Did he use the same version of the web server software? Maybe, maybe not. This inconsistency is called configuration drift, and it's the silent killer of IT stability. It's the source of those mystery outages that happen at 3 in the morning. Now, what happens when the marketing campaign is a massive success and you don't need one new server, you need 50? Do you ask Dave to cancel his weekend and spend the next 48 hours clicking and typing, hoping he doesn't make a single mistake across all 50 machines? That's not a strategy for growth. That's a recipe for burnout and disaster. Infrastructure as Code flips this entire model on its head. It says, stop treating your servers like pets you raise by hand. Start treating them like cattle raised from a repeatable, identical template. Instead of logging in and issuing commands, you write a file. A simple text file. This file is your blueprint. It's your recipe. In this file, you declare the state you want. You don't say how to build it. You just describe what you want. I want a virtual server. Its name is WebApp01. It needs 4 CPUs and 16 gigabytes of memory. It should run the Ubuntu operating system, version 22.04. It needs this security patch applied, and these specific ports open on its firewall. You write this description down using a tool like Terraform or Ansible. Think of these tools as hyper-efficient master chefs. You hand them the recipe and they go into the kitchen, your cloud provider, your data center, and they build it. Perfectly. Exactly to specification. Every single time. They read your definition and translate it into the hundreds of clicks and commands that Dave used to do by hand. And they do it in minutes, not hours. Need 50 servers now? You don't write 50 new recipes. You take your one recipe and change a single line. Count equals 50. You run the command and you go get a cup of coffee. By the time you get back, your 50 identical, perfectly configured servers are ready and waiting. This is the difference between building a car by hand and using a modern automated assembly line. One gives you a unique, expensive, and slow-to-build classic. The other gives you a fleet of reliable, identical, and instantly available vehicles ready to do business. But the real magic, the part that truly transforms a business, happens next. Where do you store this text file, this recipe for your infrastructure? You store it in the same place software developers have stored their code for decades. A version control system, like Git. And this changes everything. Suddenly, your infrastructure isn't a black box anymore. It's a transparent, auditable text file. You have a perfect time-stamped history of every single change ever made. Who wanted to open a new firewall port? It's right there in the changelog with their name next to it. Why was the memory on the database server increased? The commit message explains the performance issue it was meant to solve. You now have complete accountability. No more guessing. No more "I don't know who changed that." You can see the entire history of your environment. For any company dealing with compliance, whether it's HIPAA for healthcare or PCI for finance, this isn't just a nice to have. It's a revolutionary leap forward in security and governance. It also unlocks a new level of collaboration. Your entire team can look at the same infrastructure files. They can suggest changes, review them for errors, and approve them before they ever go live. The same way developers review code. It stops being one person's tribal knowledge and becomes a shared, documented, and peer-reviewed company asset. And then there's the ultimate safety net: disaster recovery. Imagine the worst-case scenario: a fire, a flood, a catastrophic failure that wipes out your entire primary data center in Virginia. The old way: panic, frantically searching for backups, digging through outdated documentation, and spending weeks, maybe months, trying to rebuild everything from memory. The business is down, customers are furious, money is hemorrhaging. The infrastructure as code way? It's a completely different story. You take a deep breath. You open your laptop. You find your infrastructure code, which was safely stored in the cloud. You change one line of code that says region equals us east 1 to region equals us west 2. You point it at your backup data center in Oregon. You type apply, and you watch as the automation tools begin to flawlessly recreate your entire business infrastructure. Your servers, your databases, your load balancers, from scratch, exactly as it was just hours before the disaster. What used to be a company-ending event becomes a manageable incident, solved in hours, not months. This is not a futuristic fantasy. This is how the most resilient and successful companies on the planet operate right now. This is how a small e-commerce shop in Ohio can have the same level of reliability and scalability as Amazon. It levels the playing field. It transforms IT from a slow, reactive cost center into a strategic enabler of the business. It allows you to move faster, to experiment, to innovate, knowing you have a consistent, reliable, and recoverable foundation underneath you. By codifying your infrastructure, you are creating a digital twin of your IT environment, one that is documented, versioned, and, most importantly, executable. You've taken the first, most critical step away from manual toil and toward intelligent automation. We've applied this principle to our servers and our cloud environments. But there's one area that has often been left behind: the last bastion of manual configuration, the complex web of physical devices that connects everything together. The network, the routers, the switches, the firewalls. How do we take these same infrastructure as code principles and apply them to the very fabric of our digital world? How do we turn cryptic command line interfaces and vendor-specific quirks into a single, unified, automated system? That is the next piece of the puzzle, and it's where the true power of network automation begins to shine. The answer lies in creating a universal language, a Rosetta Stone for the digital age. We don't try to force a Cisco switch to speak Juniper, or a Palo Alto firewall to understand an F5 load balancer. That's a fool's errand. Instead, we build a layer on top of them, a translation layer that allows us to speak one simple, human-readable language, which is then automatically translated into the native tongue of each individual device. This translation layer is built on two fundamental pillars: APIs and automation frameworks. Let's start with APIs. That's API, which stands for Application Programming Interface. Now I know what you're thinking. An acronym. This is where it gets complicated, right? Wrong. An API is one of the simplest, most elegant concepts in all of technology, and you use them dozens of times a day without even realizing it. Think of it like this: you're sitting in a classic American diner. You want a cheeseburger and a milkshake. You don't walk into the kitchen, grab a raw patty, find the cheese, fire up the grill, and blend the ice cream yourself. That would be chaos. It's inefficient, you'd probably make a mess, and you don't even know the diner's secret sauce recipe. Instead, you interact with a waiter. The waiter is your interface to the kitchen. You give the waiter a simple, well-defined order from a menu. I'll have the number 5 with a vanilla shake. You don't need to know how the grill works, what brand of cheese they use, or the exact temperature of the fryer. You just need to know how to order from the menu. The waiter takes your request to the kitchen, the complex system, does its work, and the waiter brings you back exactly what you asked for. That waiter, that is an API. It's a clean, simple, documented way for two different systems to talk to each other without needing to know the messy, complicated details of how the other one works. Your phone's weather app uses an API to ask a massive weather service, "What's the temperature in Boise, Idaho?" It gets a simple answer back, 55 degrees and sunny, without needing to understand the complex satellite data and meteorological models behind it. Now let's apply this to our network. For decades, network engineers had to be the chef. They had to walk into the kitchen of every single device, using that cryptic command line interface, and cook everything from scratch. But modern network devices from Cisco, Arista, Juniper, you name it, now come with APIs. They have a waiter. This means we can stop logging in manually. Instead, we can write a simple script, a small program that sends an order to the device's API. An order like, "Hey, switch 27, I need you to configure port number 15 for the new marketing department server." Or, "Firewall 01, please add this new rule to block suspicious traffic from this specific address." The program sends the request in a standardized format, and the network device's API brings back a response. "Order confirmed. Port 15 is configured." Or error, "That IP address is invalid." Suddenly, the task is repeatable. It's precise. It's documented. We've moved from being a short order cook, frantically trying to manage a dozen pans on the stove, to being the diner manager, systematically placing orders to a well-trained staff. Let's make this real. Imagine a mid-sized e-commerce company based out of Austin, Texas. Let's call them Lone Star Provisions. They're growing fast, and they need to spin up a new web server to handle the holiday shopping rush. The old way, a network engineer gets a ticket. He manually logs into the core switch to assign a VLAN. Then he logs into the firewall to create new access rules. Then he logs into the load balancer to add the new server to the pool. Each step is manual. Each step is a chance for a typo, a forgotten command, a critical human error that could bring the whole website down on Black Friday. The whole process could take hours, maybe even a day, depending on approvals and workload. With an API-driven approach, the process is transformed. The server team uses their own automated tool to build the new web server. When it's ready, that tool automatically makes an API call to the network. It sends a single pre-approved order that says, "I have a new web server named WebProd25. Please provision all necessary network services for it." The network automation system receives this order. It then talks to the switch's API to configure the port. It talks to the firewall's API to add the correct security rules. It talks to the load balancer's API to add the server into the live traffic rotation. The entire process, which once took hours of manual, nerve-wracking work, is now completed flawlessly in under 30 seconds. That's the power of the API. It's the how. It's the waiter that lets our systems talk. But that brings up another question. If the APIs are the waiters, who is placing the orders? Who is the manager of this entire restaurant? Ensuring that the server team's order, the security team's order, and the network team's order all work together in perfect harmony. You can't just have 100 different scripts making random API calls all over the place. That would be a different kind of chaos. You need an orchestrator, a conductor for your IT symphony. This is the second pillar, automation frameworks. Tools like Ansible, SaltStack, or platforms like Nautobot. These are the master conductors. They hold the sheet music for your entire IT infrastructure. An automation framework doesn't replace the APIs. It uses them, directs them, provides the logic and the workflow. Let's focus on one of the most popular frameworks in America today, Ansible. The beauty of Ansible is its simplicity. It's designed to be human-readable. The sheet music it uses is a simple text file called a playbook. You can write a playbook that describes the desired state of your system in plain English. For example, a playbook might say, "Ensure the web server VLAN exists on these 10 switches. Ensure the firewall has a rule allowing traffic on port 443. Ensure the load balancer knows about these 5 web servers." You write this one playbook. Then you press a button. Ansible takes that playbook and becomes the conductor. It reaches out to each device. It uses the Cisco API to talk to the switches. It uses the Palo Alto API to talk to the firewall. It uses the F5 API to talk to the load balancer. It translates your one simple human-readable playbook into the dozens of specific vendor proprietary commands needed to make it happen. And most importantly, it's idempotent, which is a fancy word for a simple, powerful idea. If you run the same playbook twice, it won't break anything. If the network is already in the correct state, Ansible simply recognizes that and makes no changes. This prevents the accidental misconfigurations that plague manual operations. Let's go back to Lone Star Provisions in Austin. Their network engineer doesn't have to write a custom script for every little task anymore. She writes a single Ansible playbook called newwebserver.yml. It's her master recipe. Now, whenever the server team needs a new server, they don't even need to file a ticket. The provisioning system automatically triggers that one Ansible playbook. The conductor raises its baton. The playbook runs. It checks the switches, the firewall, the load balancer. It makes only the necessary changes. 30 seconds later, the new server is live, secure, and taking customer orders. What did this accomplish? It's not just about speed, it's about consistency. Every new server is configured exactly the same way. No more "oops, I forgot a firewall" rule moments. It's about collaboration. The server team and the network team are no longer throwing tickets over a wall. Their automated systems are now working together seamlessly. And it's about agility. When a sudden spike in traffic hits, they don't have a frantic all-hands-on-deck emergency. They just run the playbook 3 more times. 3 new servers online in under 2 minutes. They've turned a business crisis into a routine, push-button operation. This is the fundamental shift. We're moving away from treating our network devices like individual pets, each with its own name, its own quirks that we have to log into and care for manually. We're moving towards treating our network like cattle, or more accurately, a fleet. A unified system that can be managed and directed as a whole from a single point of control. The combination of APIs, the universal translators, and an automation framework like Ansible, the master conductor, is what makes this possible. It's how we turn that Tower of Babel, that chaotic mess of different vendors and command lines, into a harmonious orchestra. But here's the thing. This all sounds incredible. Sounds like the future. For many businesses, though, it also sounds big. Intimidating. Where on earth does a company, a real-world American business with an existing network and a busy IT team, even begin this journey? You can't just flip a switch and automate everything overnight. What is the very first step? How do you go from manually logging into switches today to running your first simple, successful automation tomorrow? That first step is often the hardest, but it's also the most critical. And figuring out what that step looks like is our next challenge. So let's define that first step. Let's make it real. Forget the grand theories and the 5-year plans for a moment. Think about a single, nagging, repetitive task. The kind of task that makes you sigh when it lands on your desk. Let me introduce you to a network engineer. We'll call him Dave. Dave works for a mid-sized logistics company in Ohio. He's smart, he's capable, but he's buried. One Tuesday morning, a security bulletin comes out. A minor vulnerability was found in the network time protocol service on their brand of switches. The fix? Simple. Just log into every switch and change the public NTP server address to a new, more secure one. A one-line command change. Easy, right? Except Dave has 217 switches spread across 3 warehouses and a corporate office. So what does Dave's day look like? He opens his secure terminal. He opens a spreadsheet with the IP addresses of every switch. He puts on his headphones, maybe starts a podcast, and he begins the grind. He types in the first IP address. He waits for the login prompt. He types his username. He types his password. He gets into the switch. He enters enable mode. He types the enable password. He types configure terminal. He types the command to remove the old NTP server. He types the command to add the new NTP server. He types end. He types write memory to save the configuration. He types exit. 1 down. 216 to go. He copies the next IP address from the spreadsheet. He pastes it. He waits. He types his username. He types his password. You get the picture. An hour goes by. He's done maybe 30 switches. His fingers are starting to ache. He accidentally types his password into the username field on one switch, locking himself out for 5 minutes. On another, he gets distracted by an urgent email and forgets to save the configuration. He won't discover that mistake for weeks. Halfway through, around switch 110, he starts to get sloppy. He mistypes an IP address and ends up trying to log into a printer. The monotony is brutal. It's not just boring. It's a minefield for human error. By the end of the day, Dave is mentally fried. He's spent 6 hours of his life being a human robot, performing a task a machine could do in minutes. He hasn't done any creative work. He hasn't planned the new network upgrade. He hasn't troubleshot the intermittent Wi-Fi issue in the warehouse. He has only changed a single line of text over and over and over again. Dave's story isn't unique. It's the story of IT professionals all across America. This is the daily reality that burns people out. This task, this NTP update, is the perfect place to start. It is our target zero. Your first step into automation isn't about trying to automate the entire network build-out for a new branch office. That's like deciding to learn to cook by attempting a 5-course Michelin star meal. You'll fail, you'll get frustrated, and you'll decide cooking isn't for you. No, your first step is learning how to perfectly boil an egg. You need to pick a target zero, a task that is 1. Highly repetitive, like Dave's NTP update. Anything you do more than a handful of times a month is a candidate. Too low risk. Changing an NTP server is a great example. If the automation fails, what's the worst that happens? The clock on a switch might be off by a few seconds until you fix it. The network doesn't go down. You're not changing a core routing protocol. We're not doing open heart surgery on our first day of medical school. And 3, easily verifiable. After you run the automation, can you quickly and easily check if it worked? For the NTP server, you can just log into a few random switches and run a show command. The proof is right there. So, Dave's NTP update is our perfect target 0. Now, what does the automation itself actually look like? This is where people get intimidated. They imagine thousands of lines of complex code. But for this first step, it's nothing like that. Think of it not as a program but as a recipe. A simple 3-part recipe for your computer to follow. We're going to use a tool called Ansible to do this, but you don't even need to worry about the name right now. Just focus on the recipe. Part 1 of the recipe is the ingredient list. It's just a simple text file. We call it an inventory file. And all it contains is a list of the IP addresses or host names of all your switches. That spreadsheet Dave was using? That's basically it. You just list them out one per line. 217 lines, 217 switches. That's it. You've just told the recipe what devices you want to cook with. Part 2 of the recipe is the key to the kitchen. You need a way to log in. So, you securely store the username and password the automation will use. Modern tools do this in a very secure way, often called a vault. So you're not just typing passwords in plain text. For now, just know that you give the recipe the credentials it needs to open the door to each switch. Part 3 is the most important. The instructions. This is called a playbook. And here's the magic. The instructions are written in a way that is almost plain English. You don't need to be a programmer to read it. It would look something like this. First, you'd say, "Hey, I want to run this on all the devices in my switches ingredient list." Then you'd say, "The task is to configure these devices." And then you'd list the exact commands you want to run. Literally, the same commands Dave was typing by hand. Command 1. No NTP server 1.2.3.4. Command 2. NTP server 5.6.7.8. And that's the core of it. You've created a simple text file that lists the devices, a secure way to provide credentials, and a playbook that says, log into these devices and type these specific commands. Now let's rewind. It's Tuesday morning. The security bulletin comes out. But this time we have our recipe. Dave doesn't open his spreadsheet to start a 6-hour grind. Instead, he opens his inventory file and makes sure all 217 switches are listed correctly. He opens his playbook and double-checks that the 2 command lines, the old server to remove, the new one to add, are perfect. He takes 5 minutes to review his work. Then, he runs a single command from his computer. Ansible playbook update ntp.yml. And he watches. His screen comes alive. The system says, connecting to switch warehouse 1. A moment later, okay. Then, connecting to switch warehouse 2. Okay. Connecting to switch office 10. Okay. One by one, like a perfectly disciplined army of robots, the automation is logging into every single switch, entering the commands precisely as he wrote them, and saving the configuration. There are no typos. There are no distractions. There's no fatigue. It is flawless, methodical execution. In less than 10 minutes, it's done. A sea of green OK messages on his screen. 217 switches have been updated. The 6-hour soul-crushing task that was Dave's entire Tuesday is now finished before he's even done with his first cup of coffee. What does Dave do with the other 5 hours and 50 minutes of his day? He can finally investigate that tricky Wi-Fi problem. He can start planning the next-generation firewall deployment. He can add real strategic value to his company. He has been elevated from a human keyboard to a technology strategist. This first victory is everything. It's not about the time saved on this one task. It's about the psychological shift. It's the proof. It proves to you, to your team, and to your boss that this isn't some mythical, unobtainable fantasy. It's a real practical tool that solves real painful problems. That simple playbook is now an asset. The next time an NTP server needs to be changed, the work is already done. It's a tool in the toolbox ready to go. You've built your first building block. You've taken that first critical step from manual toil to automated power. You've boiled the egg perfectly. But this is just the beginning. We've just pushed a command out. We've talked to the network. But what about listening? What about having the network talk back to us? How do we go from just changing configurations to gathering information, checking the health of hundreds of devices at once, and using automation to find problems before our users even know they exist? That's where the real power starts to unlock. This leap from simply commanding the network to asking it questions is the difference between being a network mechanic and a network doctor. A mechanic fixes the car after it breaks down on the side of the highway. A doctor performs a regular checkup to find the small problem before it becomes a catastrophic one. For years, network engineers have been forced to be mechanics. We wait for the phone to ring, for the ticket to pop up in the queue, and the complaint is almost always the same vague and frustrating phrase: the internet is slow. Think about what happens next the traditional manual way. A ticket comes in from the sales team on the third floor. The pressure is on. Sales can't process orders, they can't run demos. Every minute of downtime costs the company real money. So you, the engineer, begin your digital detective work. You open your terminal. First, you SSH into the main switch on that floor. You run show interface status to see if the ports are up. They are. Then you run show interface counters to look for errors. You're sifting through a mountain of text, looking for a number that seems out of place. Nothing obvious. Okay, what's next? Maybe it's the wireless. You log out of the switch and log into the wireless controller. You find the access point for that area. You check its client load. Looks a little high, but is it too high? You check the signal strength for the specific users who complained. Seems okay. You check the channel utilization. Maybe there's interference from a neighboring business. It's a possibility, but you can't be sure. The clock is ticking. Now you're thinking bigger picture. You log out of the wireless controller and into the core router. You check the routing table. Looks fine. You check the utilization on the main internet-facing interface. It's high, but it's the middle of the day, it's always high. Is it higher than normal for a Tuesday at 11 a.m.? You don't know. You don't have that data. You're guessing. You're reacting. You're pasting outputs into a text file, trying to piece together a puzzle with half the pieces missing. All while users are getting more and more frustrated. This process can take hours, even days of painstaking, manual, repetitive work. It's stressful, inefficient, and it keeps you from working on the projects that actually move the business forward. Now let's rewind. Let's apply the principles of automation, not to push a change, but to pull information. To become the network doctor. Instead of waiting for the ticket, imagine a script. A simple Python script, maybe using a library like Netmiko or Napalm, that runs automatically every 15 minutes like clockwork. This script isn't changing anything. It's just asking questions. It's performing a health check. What does it do? It has a list of all your critical network devices. And for each device, it logs in and runs a specific set of commands, the very same commands you were just running manually. On every switch, it runs show interface counters errors. But instead of you having to visually scan for a non-zero number, the script does it for you. It parses the output and looks for things like CRC errors, runts, or giants, the silent killers of network performance that often point to a bad cable or a failing network card. If it finds any port with errors that have increased since the last check 15 minutes ago, it doesn't just know, it acts. It can log that information to a central file, or better yet, send a targeted alert to your team chat. Alert. Interface Gigabit Ethernet 1/0/24 on sales floor. Switch 1 is showing a high rate of CRC errors. But it doesn't stop there. The same script connects to the wireless controller and pulls the number of clients on each access point. It checks the CPU and memory utilization on the core routers. It connects to the firewall and checks the number of active sessions. It even performs a simple ping test to a reliable external source, like Google's DNS at 8.8.8.8, and records the latency. Suddenly, you're not dealing with a mountain of raw, disconnected text. You have structured data. Every 15 minutes, you get a snapshot of your network's vital signs. The script can write this data to a simple text file, a CSV, or even a database. And this is where the magic truly begins, because a single data point is just a number. But a series of data points over time? That's a story. That's a baseline. You're no longer asking, is the internet slow right now? You're asking, how does the network's performance right now compare to every other Tuesday at 11 a.m. for the past 3 months? This is the concept of baselining. Your automation script isn't just a spot checker. It's a historian. It builds a profile of what normal looks like for your network. So when that internet utilization on your core router hits 85%, your script doesn't just see a number. It compares it to the baseline and says, hold on. For the last 12 Tuesdays at this exact time, utilization has never gone above 70%. Something is different. Something is wrong. It can then trigger an alert, giving you a heads up before anyone even notices a problem. You've gone from reactive to proactive. Let's go back to our slow internet ticket from the sales team. In this new world, the ticket might never even be created. At 9:15 a.m. your health check script runs. It connects to the third floor switch and sees that the error counters on port 24, the one connected to their main access point, have jumped by 1,000 in the last 15 minutes. The script automatically sends a message to your IT team Slack channel. Proactive alert. High CRC errors detected on port GI1/0/24 of switch, sales floor 3. This port connects to access point, AP sales 01. Recommend physical cable inspection. Before a single user picks up the phone, you know the exact switch, the exact port, the likely cause of the problem, a faulty patch cable, and the specific users who will be affected. An engineer goes up, swaps out a $5 cable, and the problem is solved in 10 minutes. Compare that to the hours of stressful manual troubleshooting we talked about before. That is the power of using automation for observability. You're not just faster, you're smarter. You're using data to make informed decisions. And the beauty of this is its scalability. Manually checking the error counters on 200 switches across 3 buildings would be an entire week's work. A script can do it in less than 5 minutes. It doesn't get tired. It doesn't make typos. It doesn't forget to check the one switch in that dusty old wiring closet. Performs the same thorough check every time on every device. This isn't a futuristic fantasy. This is what businesses across America are implementing right now. They're starting small, maybe with a script that just pings all their servers to check for latency. Then they expand it to check interface status. Then they add error checking. Then they add CPU and memory monitoring. Each step builds on the last, creating a richer and richer picture of the network's health. They're turning their networks from a black box, where problems are a mystery, into a transparent system that tells them when it's not feeling well. We've moved beyond just telling the network what to do. We're now having a conversation with it. We're listening to what it's telling us, second by second, minute by minute. We've built a system that can see a problem coming. But this raises the next, even more powerful question. If our automation can detect a problem with such precision, could it also be trusted to fix it? What if, when that script detected a problem, it didn't just send an alert but took the first step to remediate it all on its own? That's the road to a truly self-healing network, and it's where we're going next. This shift from passive monitoring to active remediation is not just an evolution, it's a revolution. It's the difference between a smoke detector that beeps and a sprinkler system that puts out the fire. One tells you there's a problem, the other solves the problem for you, often before you even knew it existed. This is the core promise of a self-healing network, to transform your IT infrastructure from a fragile system that needs constant human care into a resilient, intelligent organism that can fend for itself. But let's be honest, the idea of a script automatically making changes to your live production network can be terrifying. For years, the cardinal rule of network engineering has been measure twice, cut once. Every change was meticulously planned, peer-reviewed, and executed during a scheduled maintenance window, usually in the dead of night. The thought of a machine making those changes on the fly, in the middle of a business day, seems to run counter to decades of best practices. Feels like handing the keys to the kingdom to a robot. So how do we bridge this gap? How do we build the trust required to let automation take the wheel? The answer is, you don't just flip a switch. You build trust incrementally. You start with a simple, powerful concept known as closed-loop remediation. It's a 3-step dance. Observe, decide, and act. First, your system observes the state of the network. This is the monitoring we've already talked about, collecting telemetry, checking health, looking for anomalies. Second, based on that observation, it decides on a course of action. This is the crucial part. The machine isn't thinking in the human sense. It's executing a predefined, human-approved playbook. You, the expert, have already laid out the rules. You've said, if you see this specific problem, under these specific conditions, then you are authorized to take this specific action. Finally, the system acts. It executes the pre-approved command to fix the issue. Let's make this real. Imagine a mid-sized e-commerce company in Dallas, Texas. Their entire business depends on their website being fast and responsive, especially during a big sale. They have a web server farm, and one of the network switches connecting those servers has a port that's starting to act up. It's not dead, not yet, but it's intermittently dropping packets. This is causing random, frustrating slowdowns for customers trying to check out. In the old world, here's what happens. Eventually, a customer complains, or a monitoring system sends a vague, high-latency alert. The network engineer, let's call her Maria, has to drop everything. She logs in, starts running diagnostics, and begins the painful process of elimination. Is it the server? The application? The firewall? Maybe the internet provider? After 20 minutes of frantic troubleshooting, she finally isolates the issue to that single, faulty switch port. Now she has to manually move the server's connection to a different port, a process that involves logging into the switch, deactivating the bad port, configuring a new one, and then verifying that everything is working again. All told, it's a 30-minute fire drill, during which time dozens of sales were lost and customer trust was eroded. Now let's see how this plays out in a self-healing network using that observe, decide, act loop. Step 1. Observe. The network automation platform is constantly monitoring the error counters on every single switch port in the data center. It sees that port number 24 on switch A is showing an unusual number of outbound discards and CRC errors. This isn't a guess, it's hard data. The observation is made within seconds of the problem starting. Step 2. Decide. The system checks its rulebook, the playbook written by Maria weeks ago. The rule says, if a server-facing port shows more than 1,000 CRC errors within a 60-second window, and if there is a spare, unused port available on the same switch, then trigger the port failover automation. The conditions are met. The decision is instantaneous. Step 3. Act. The automation script kicks in. It doesn't need to ask for permission, it already has it. The script automatically identifies the server connected to the faulty port. It then accesses the switch's configuration, finds a spare port, and copies the exact configuration, the VLAN settings, the security policies, everything from the bad port to the good one. It then disables the faulty port and enables the new one. Finally, it runs a quick series of tests to confirm the server is back online and passing traffic cleanly. The result? The entire process from detection to resolution takes less than 15 seconds. Maria doesn't get a frantic phone call. She gets a notification in her team's chat channel that says, automated remediation. Detected high error rate on switch A, port 24. Migrated connection to port 25. Service restored. No user impact detected. Think about the profound difference here. In the first scenario, the IT team is a reactive emergency service. Their value is measured by how quickly they can fix something that's already broken. In the second scenario, the IT team are the architects of a resilient system. Their value is measured by the fact that the business never even felt the problem in the first place. They've elevated their work from fighting fires to designing a fireproof building. This isn't just for faulty switch ports. This same observe, decide, act model can be applied to countless scenarios. Is an internet link becoming saturated with traffic? An automation can decide to reroute less critical traffic, like data backups, over a secondary connection to preserve bandwidth for sales transactions. Is a web server running out of memory? An automation can decide to gracefully restart the application service during a period of low traffic. Has a security system detected a suspicious device on the network? An automation can instantly act to quarantine that device, blocking its access to critical resources until a human analyst can investigate. Each of these automated remediations starts small. You don't begin by letting the system reconfigure your entire core network. You start with something simple and low risk, like the switch port example. You build a clear, precise playbook. You test it. You let it run in a read-only mode first, where it just tells you what it would have done. You watch it, you refine it, and you build confidence. Once you see it work flawlessly a dozen times, you trust it. Then you move on to the next problem and the next and the next. This is how you build a truly resilient infrastructure. You're not just waiting for things to break. You are creating a system that anticipates and resolves its own failures in real time. It's a network that doesn't just support the business. It actively protects it. The human engineers are freed from the tyranny of the urgent, the constant, soul-crushing cycle of break-fix tickets. They can finally focus their talent on bigger, more strategic projects, the projects that actually move the business forward. But this all begs a very important question. This sounds incredible, but it also sounds incredibly complex. What are the actual tools that make this happen? Is this something only giant tech companies with massive budgets and armies of developers can achieve? Or is it accessible to that e-commerce company in Dallas or a manufacturing firm in Ohio? What does the toolbox for building a self-healing network actually look like? That's exactly where we're headed next. The first thing to understand about this toolbox is that it's not some mythical, diamond-encrusted chest locked away in a Silicon Valley vault. It's more like a professional-grade workshop, filled with powerful, specialized tools that are increasingly available to everyone. The secret isn't owning a billion-dollar hammer. It's knowing how to use the right combination of tools to build something incredible. And today, those tools are more accessible than ever before, thanks in large part to the open-source community and a fundamental shift in how we think about network infrastructure. Let's break down the 3 essential pillars of any modern, automated network. Think of it as the brain, the blueprint, and the nervous system. Get these 3 things right, and you're on the path to a self-healing network. First, you have the brain. This is the automation and orchestration engine. This is the master conductor. In the past, a network engineer was the conductor, manually telling each device, each musician in the orchestra what to do one by one. Router, add this rule. Switch, change this setting. It was slow, tedious, and prone to human error. A single wrong note could ruin the entire performance. The modern brain is a software platform. You've probably heard of some of them. Ansible, SaltStack, or Puppet. Or maybe vendor-specific platforms like Cisco DNA Center or Juniper Apstra. What these tools do is revolutionary. You no longer talk to individual devices. You talk to the brain. You give it the sheet music, a high-level description of what you want the entire orchestra to sound like. You say, I need a secure network for the new marketing department with access to these servers and no access to the finance database. You write this intent once in a simple human-readable language. The brain then takes that intent and translates it into hundreds or even thousands of specific low-level commands. It then communicates with every single device simultaneously, ensuring they are all perfectly in sync, playing the right notes at the right time. It's the difference between coaching every single player on a football team individually versus giving the entire team a single, elegant play to execute flawlessly. This is the engine of change. But a brain with no memory or plan is just chaos. It needs a definitive guide. This brings us to the second pillar, the blueprint. In the industry, we call this the single source of truth, or SOT. This is, without a doubt, one of the most critical and transformative concepts in modern IT. For decades, the truth of a network lived in a messy collection of outdated spreadsheets, forgotten diagrams in Visio, and most often, in the heads of a few senior engineers. It was a recipe for disaster. If that engineer left or if that spreadsheet was wrong, you were flying blind. A source of truth, using tools like Netbox or Nautobot, changes the game completely. It is a centralized database that holds the intended state of your entire network. Not the current state, which might be broken or misconfigured, but the perfect, ideal, desired state. It's the master architectural blueprint for your digital building. It defines every IP address, every VLAN, every cable connection, every device role. It states with absolute authority that this port should be connected to that server, and this link is the designated backup path for that main fiber line. Why is this so powerful? Because now the automation brain has a perfect reference. It can constantly compare the real world, the actual state of the network, against the blueprint. If it finds a discrepancy, it knows something is wrong. It's not guessing. It's not relying on a 5-year-old diagram. It's comparing reality to the one universally agreed upon truth. And when it needs to make a change, it consults the blueprint first to understand the relationships between all the components, ensuring a change in one area doesn't accidentally break something else 3 states away. So we have the brain to make changes and the blueprint to guide those changes. But how does the system know when something is broken in the first place? That's the third pillar, the nervous system. This is the world of modern telemetry and observability. For years, network monitoring was like a doctor checking your pulse once every 5 minutes. The system, using a protocol called SNMP, would ask each device, "Hey, are you okay?" And the device would reply, "Yep, I'm okay." It was slow, inefficient, and you only found out about a problem long after it happened. Modern telemetry is a complete reversal of this. It's like a continuous EKG for your network. Instead of the system asking, the devices tell. They stream a constant, real-time fire hose of data about their health. CPU utilization, memory, interface errors, packet drops, latency, everything. The moment a fiber optic cable is cut, the device on either end doesn't wait to be asked. It screams in real time, "My connection is gone." This data flows into observability platforms, tools like Prometheus, Grafana, or the ELK stack, which are designed to drink from this fire hose of information. They can visualize the data, but more importantly, they can spot anomalies. They can see the patterns that precede a failure, and critically, they can trigger an action the microsecond a threshold is crossed. Now let's put it all together. Let's go to that manufacturing firm in Ohio we talked about. It's 2:37 a.m. A forklift driver accidentally snags a fiber optic cable running between two critical switches, connecting the warehouse floor to the inventory servers. The link goes dead. In the old world, a chain reaction of failure begins. The warehouse scanners stop working. The shipping department can't process orders. The night shift manager starts making frantic phone calls. Eventually, a network engineer is woken up. He has to groggily log in, try to figure out what's wrong, remember which switches are involved, find the documentation for the backup path if it even exists, and then manually type in the commands to reroute traffic, praying he doesn't make a typo. The whole process could take an hour, maybe more. That's an hour of lost productivity, lost revenue. Now let's see how our automated system handles it. The exact same moment that cable goes dark, the nervous system fires. The switches on both ends instantly stream telemetry data saying, Interface 24 is down. This isn't 5 minutes later. It's immediate. The observability platform catches this data, recognizes it's a critical failure, and instead of just sending an email, it triggers a pre-programmed alert directly to the brain, our automation engine. The brain wakes up. Its first move? It consults the blueprint, the source of truth. It asks, what is the intended state for this part of the network? The blueprint immediately shows that the failed link has a designated, pre-approved backup path through a secondary switch. It knows the exact ports, the exact configurations, the exact IP addresses required. There is no guesswork. Armed with this flawless information, the brain springs into action. It connects to the necessary switches and, in a matter of seconds, executes the precise, pre-tested series of commands to deactivate the failed path and bring the backup path online. It then runs a series of automated checks to verify that data is flowing again. Finally, it integrates with the company's IT ticketing system, automatically opening a ticket that says, Critical link failure detected at 2:37 a.m. Automated failover to backup path completed at 2:37 a.m. Primary link requires physical inspection. The night shift manager sees his scanners blink for a moment and then come right back online. The engineer in charge of the network wakes up at his normal time, sees the ticket, and sips his coffee, knowing the emergency was handled before it ever became one. He can now calmly dispatch a technician to fix the physical cable, instead of spending his morning fighting a fire. This isn't science fiction. This is happening right now. The tools, Ansible, Netbox, Prometheus, many of them are open source and free. The knowledge is out there. It's no longer a question of whether this is possible for a business in Dallas or Ohio. The question is, are they ready to embrace a new way of thinking? Because having the tools is one thing, but changing the culture of an IT department, shifting the very mindset of your engineers from manual operators to automated architects, that's the next great challenge. It's a transition that trips up more companies than any piece of technology ever could, because the real friction in network automation isn't in the code, it's in the corridor, it's in the team meetings, it's in the mind of that brilliant seasoned engineer who can configure a router in their sleep using the command line, and who now sees a script as a threat, not a tool. This isn't a technical problem, it's a human one. And to solve it, we first have to understand the fear. Let's be brutally honest. For many network engineers, the rise of automation sounds like the thunder of approaching obsolescence. It's the fear that the very skills that made them valuable, their deep knowledge of command line syntax, their years of hands-on troubleshooting, are about to be devalued, replaced by a Python script. They hear automation, and they think, they're trying to automate me out of a job. This is the primary, most powerful source of resistance. Then there's the fear of the unknown. An experienced engineer has a tactile relationship with the network. They feel its rhythms through the command line. It's familiar, it's comfortable, it's predictable. Automation tools like Ansible, Python, and Git? That's a whole new universe. It's learning to code, to think like a developer. It feels like being asked to give up your native language and become fluent in another, overnight. It's intimidating. And finally, there's the fear of losing control, which is tied to the fear of catastrophic failure. When you're making a change on a single device, you are in complete control. Your hands are on the keyboard. If something goes wrong, you can immediately back it out. But a script? A script can make a change to 500 devices in 5 seconds. A single typo, a misplaced variable, could theoretically cause a network-wide outage. The logic becomes, I trust myself to not make a mistake on one box, more than I trust a script to not make a mistake on all of them. These fears are valid. They are real. And any leader who dismisses them with a hand wave and a memo about digital transformation is doomed to fail. To overcome this cultural hurdle, you don't fight the fear. You reframe the future. You have to fundamentally change what it means to be a network engineer. You have to transform your team from firefighters into architects. Think about the traditional role. It's the firefighter. The pager goes off at 2 a.m. There's an outage. You are the hero. You rush in, dive into the command line, troubleshoot the issue under immense pressure, and restore service. You get the praise, the adrenaline rush, the satisfaction of having saved the day. The entire culture of IT has often been built around rewarding this heroism. The problem is, a firefighter's job is to react to disasters. You're always living on the back foot, perpetually waiting for the next alarm. It's a cycle of stress and burnout. It doesn't scale, and it certainly doesn't innovate. Now imagine the architect. The architect doesn't wait for the building to burn down. The architect designs the building with fire suppression systems, with resilient materials, with intelligent escape routes. The architect's goal is to design a system where the fire never starts in the first place. This is the new network engineer. Their job isn't to heroically fix outages. It's to build an automated, self-healing network where those outages are engineered out of existence. Their value isn't measured in tickets closed, but in the reliability and agility of the system they've designed. They spend their time building workflows, testing code, and thinking about the big picture, not typing the same 5 commands over and over again. It's a shift from reactive, manual labor to proactive, intellectual design. This is not a demotion. It is the single greatest promotion in the history of the profession. So how do you guide your team on this journey from firefighter to architect? It starts with a single small step. You don't try to automate the entire core network on day one. That's how you prove the skeptics right when something goes wrong. You find the most tedious, repetitive, mind-numbing task your team does, and you aim the cannon of automation directly at it. Maybe it's updating the access lists on 100 branch office routers. Maybe it's configuring the VLANs on new switches. You pick one small low-risk task. You build the script, you test it, and you deploy it. And when it saves the team 10 hours of manual work that week, you celebrate that win. You make it visible. You show them, this isn't replacing you. This is liberating you from the boring stuff so you can focus on the interesting stuff. Momentum is built on a foundation of small, undeniable victories. Next, you must invest in your people. You cannot hand a carpenter a welder's torch and expect a perfect seam. You have to provide training, but not just a link to an online course. You have to carve out dedicated time for learning. Give them a lab environment, a digital sandbox where they can build, break, and fix things without any risk to the live network. Identify the engineers who are naturally curious, the ones who are already tinkering. Make them your automation champions. Empower them, train them first, and let them become the internal mentors who can guide their peers. This is far more effective than any top-down mandate. Then you have to change the rules of the game. If you continue to only reward the firefighter who stays up all night to fix a problem, you will only create more firefighters who, subconsciously or not, allow a culture where all-night problems are the norm. You need to redefine success. Start measuring and rewarding the creation of automation. Create a career path where the senior-most engineers are the ones building the most robust systems, not the ones with the most command line certifications. The incentive structure must align with the architectural mindset. When people see that the path to promotion, recognition, and reward is through building, not just fixing, the cultural shift will accelerate dramatically. And this all leads to the most profound change of all, treating your infrastructure as code. This is the philosophy that truly separates the old world from the new. Instead of configurations living on individual devices, they live as text files in a central repository like Git. This is a game changer. Suddenly, you have a complete history of every change ever made to your network. You know who made it, when they made it, and why. Want to propose a change? You don't just log into a router at midnight. You submit your change as code. It gets reviewed by your peers, the same way software developers review code, to catch errors before they ever happen. It gets tested in an automated lab. Only after it passes all checks is it deployed automatically to the network. This process demolishes the fear of breaking everything at scale. In fact, it creates a system that is infinitely safer and more reliable than any lone engineer making manual changes, no matter how skilled they are. I saw this firsthand with a logistics company out of Minneapolis. Their network team was legendary for their grit. 2 senior engineers, in particular, could practically rebuild their entire WAN from memory, but they were drowning. Every new warehouse, every store opening, was a mountain of repetitive configuration work. They were constantly flying around the country, putting out fires and falling further behind. The CIO decided to force a change. He brought in an automation platform and declared, "We will no longer make manual changes." The resistance was immediate, led by those 2 senior guys. It was a battle, but the CIO held firm. They started small, automating the configuration of a single model of switch for new stores. The script was clumsy at first, but it worked. A process that took 4 hours of manual work was now done in 2 minutes. The first aha moment. Then they built a pre-check script that would validate the health of a device before a change. It caught a subtle misconfiguration that would have caused an outage. The second aha moment. Within a year, those 2 senior engineers, the biggest skeptics, had become the most passionate advocates. They weren't just network engineers anymore. They were developers building a self-operating network. They were architects. Their job wasn't easier. It was more valuable, more engaging, and for the first time in years, they were ahead of the business's needs, not chasing them. That is the transformation. It's a journey from technician to creator, from a culture of heroic effort to a culture of intelligent design. It's about unlocking the vast, untapped potential of your most valuable asset, your people. By removing the drudgery, you free them to solve bigger, more important problems. So, once you've successfully navigated this cultural shift, when your team is armed with the tools and the architectural mindset, what comes next? What is the ultimate promise of a fully automated network? What does that truly look like for an American business? It looks like a network that thinks. It looks like a digital central nervous system for your business, one that doesn't just react to commands, but anticipates needs. The ultimate promise is a network that is not just automated, but autonomous. Imagine, for a moment, the difference between a cruise control system in a car and a true Level 5 self-driving vehicle. Cruise control is automation. It maintains a speed you set. It's helpful, it reduces some workload, but you are still fundamentally driving the car. You are monitoring traffic, you are steering, you are braking. An autonomous vehicle, however, understands the intent. Your intent is to get from your home in Chicago to a meeting in Milwaukee, safely and efficiently. You don't tell it when to brake, when to accelerate, or which lane to use. You give it the destination, the goal, and it handles the thousands of micro-decisions required to get you there. That is the ultimate promise of a fully automated network. It's the leap from command line cruise control to an autonomous, self-driving infrastructure. This future is built on 2 revolutionary concepts that sound like science fiction, but are rapidly becoming reality for businesses across the country. The first is the self-healing network. For decades, network management has been a reactive discipline. A link goes down in a warehouse in Texas, an alarm blares in an operations center in New Jersey, and an engineer is woken up at 3 a.m. to troubleshoot. It's a model based on failure. The self-healing network flips this entire paradigm on its head. Using a constant stream of telemetry data, billions of data points per second, combined with machine learning and AI, the network develops a baseline understanding of what normal looks like. It knows the typical latency between your Denver office and your cloud provider. It knows the usual traffic patterns during quarterly earnings calls. It knows the health of every switch, router, and access point. When it detects a deviation from that baseline, a slight increase in packet loss, a router's memory usage beginning to creep up, it doesn't just send an alert. It acts. It can preemptively reroute traffic around a degrading link before it fails. It can automatically adjust quality of service parameters to prioritize a video conference that's starting to stutter. It can identify a security threat, quarantine the affected device, and patch the vulnerability, all without a human being ever touching a keyboard. It's like the difference between waiting for a heart attack to call 911 and having a system that detects rising cholesterol levels and automatically adjusts your diet and exercise plan to prevent the heart attack from ever happening. It's proactive, not reactive. It's about resilience built into the very fabric of the network itself. The second and even more profound concept is intent-based networking, or IBN. This is the true destination of our journey. This is the self-driving car. For all of its power, traditional automation still requires us to speak the network's language. We write scripts in Python, we build playbooks in Ansible, we configure devices using specific arcane commands. We are still the translators, converting business needs into technical configuration. Intent-based networking eliminates the need for translation. With an IBN system, you state your business policy, your intent, in plain language. You don't say, configure access control list 101 on interface gigabit Ethernet 01 to deny traffic from subnet 10.0/24. Instead, you declare the intent. Guest users are not allowed to access the financial servers. The IBN system takes that simple, human-readable statement and does the rest. It automatically translates that intent into the specific configurations for every single device across your entire multi-vendor, multi-cloud network. It then continuously verifies that the network is adhering to that intent. It constantly asks itself, is it still true that guest users cannot access the financial servers? If a misconfiguration or a failure ever violates that intent, the system automatically remediates the issue to bring the network back into compliance. Think about the sheer power of this. A new application needs to be deployed. The application team defines its needs. This app needs high bandwidth, low latency, and must be accessible by the sales department, but completely isolated from R&D. They state their intent. The network provisions itself. A new branch office opens in Boise. The business intent is, employees in Boise need the same secure access to corporate and cloud resources as employees in our Atlanta headquarters. The network configures all the necessary routing, security, and access policies automatically. This is the end of the 500-step manual deployment checklist. This is the end of configuration drift and human error. You are no longer managing thousands of individual devices. You are managing a single holistic system through the declaration of business policies. The network becomes a true business enabler, an agile platform for innovation, not a bottleneck of tickets and change requests. So, what does this mean for the American business fighting to compete? It means speed, unprecedented speed. The ability to spin up a new retail pop-up shop for a weekend event with full enterprise-grade security and connectivity in a matter of minutes, not weeks. It means agility. When a new business opportunity arises, the network can be reconfigured to support it almost instantaneously, allowing you to seize market share while your competitors are still scheduling planning meetings. It means security. In a world of constant threats, an intent-based network that can automatically enforce security policies from the data center to the cloud to the remote employee's laptop is your single greatest defense. It's a system that doesn't just have a firewall. The entire network is a security sensor and enforcement platform, and it means incredible cost savings, not just in reduced downtime, but in freeing up your most valuable assets, your people, from the drudgery of manual maintenance. And this brings us back to the most critical question: what happens to the network engineer? What happens to the IT teams that have spent their careers mastering the command line? They are not replaced. They are elevated. They are freed. Freed from the endless cycle of break-fix, freed from the tedium of repetitive configuration tasks, freed from being gatekeepers of infrastructure. They are transformed from network mechanics into network architects. Their deep understanding of how networks function is now applied to designing the business intents, not typing the commands. They focus on optimizing performance, building more resilient systems, and partnering with the business to create new digital experiences. They stop asking, how do I configure this VLA in? And start asking, what can this network do to help us launch a new product line 3 months ahead of schedule? They become strategic assets, innovators driving real business value, not just technicians keeping the lights on. The most valuable skill is no longer memorizing commands, but understanding the goals of the business and translating them into strategic intent. This is the final destination. Network automation is not just about writing a few scripts to make life easier. It's a fundamental reimagining of what IT infrastructure is and what it can do. It's about transforming the network from a fragile collection of manually configured boxes into a resilient, intelligent, and agile platform for growth. It's about building a foundation that allows your business, whether it's a small manufacturing firm in Ohio or a financial services giant on Wall Street, to move at the speed of ideas. This journey, from manual chaos to scripted automation, and finally to intent-based autonomy, is the single most important IT transformation of our time. It's not a question of if businesses will adopt this model, but when. Those who embrace it will build a powerful, sustainable competitive advantage. They will out-innovate, outmaneuver, and outperform their rivals. They will have a network that doesn't just support the business, but actively drives it forward into the future.